today's class, we'll be looking at the third theorem when it comes to Laplace transform. So far, we've been able to look at the possible function we'll be given under Laplace transform, right? Starting from a constant function, exponential function, sine function, cosine function, in general, the trigonometric function, right? And we've implemented how questions can be given on how to use these functions, right? Then we made mention that basically when it comes to Laplace transform, we have three theorems which are the fundamentals of Laplace transform. The first one, which is the first shift theorem. The second one is multiplying by t, and the third one is dividing by t. So in today's class, we'll be looking at the third theorem, which is dividing by t. When we talk about dividing by t, the idea remains the same, right? Dividing by t, meaning all of these functions we've dealt with so far. Now say you have any of this function being divided by t, how do you then find the Laplace transform? That's what this is basically saying, right? So we are saying that, recall that when we started Laplace transform as a course, we said these are the possible functions that will be given, which is the Laplace transform, which is function of a, the first one, which is the function of a. The second one is an exponential function, meaning exponential negative at. Moving on, we have the trigonometric function, which is sine at, cos at, and the likes, right? Now say you are given any of these functions. Say you are given sine at, which implies sine at over t. How do you interpret this? Initially, what we are familiar with, this is what we are familiar with. Say this is 1 actually. Let's say this is 1. Take another function. Say you have an exponential function, say exponential negative at, which implies exponential negative at over t. Say 2. Moving on, let's take cos at. Say you have cos at, which implies cos at all divided by t. Say equation 3. So what we are saying basically is that these are the functions we are familiar with, right? Now observe the new pattern of this function. You will see that each of these functions are being divided by t, meaning that we have f of t being divided by t. So when we say dividing by t, the whole concept is that we are dividing each of these functions, any of these functions, giving any of these functions being divided by t, right? Now recall that the general formula that defines Laplace, which is the Laplace transform. Say you are looking for the Laplace transform of t, meaning find the Laplace transform of f of t. The formula becomes integral from 0 to infinity f of t exponential negative at dt. Exponential negative at dt. What this simply means is that, say you want to transform any of these functions, substitute the respective function, right? For instance, let's say you want to transform sine at. The Laplace transform of sine at, the Laplace transform of sine at becomes integral from 0 to infinity sine at exponential negative a dt, right? Moving on, let's say you want to transform the Laplace transform of exponential with power of negative at. The Laplace transform becomes 0 to infinity exponential negative at multiplying exponential, this is s, multiplying exponential negative st dt. Now observe that, say this is 1, say this is 2, say this is 3. Observe the difference between case 1, case 2, and case 3. You see that in case 1, what do we have here? This is f of t, right? Meaning for this very guy, we have f of t. In case 2, f of t is what? Sine at. We then substitute, anywhere we see f of t, we substitute what? Sine at, right? Similarly to case 3, f of t here is what? Exponential negative at. Anywhere we see f of t, we substitute what? Exponential negative at. We've done all of this previously, right? We've done all of this previously in our last class on Laplace transform. So the concept still remain the same, the idea still remain the same. In this case, your f of t, in this case, your f of t implies f of t all divided by t. Your f of t, for this very guy, theorem 3 is just saying that f of t it implies what? F of t all divided by t. F of t all divided by t, which is what I've explained here. Considering 1, 2, 3, say you are given this initial function. Now say this initial function are being divided by t. How do you then find the Laplace transform, right? How do you then find the Laplace transform? So this is what this theorem is saying. This is what theorem 3, which is dividing by t theorem is saying. The same way we solve for this, meaning anywhere we see f of t, we substitute the function that we want to find the Laplace transform. So if this is the function we want to find the Laplace transform, it means that we are going to substitute this very function into the general formula that defines Laplace, right? So we are saying that the Laplace transform of f of t all divided by t is equals to the integral from 0 to infinity. In this case, what is the f of t? F of t over t. So substitute, you then have f of t over t exponential negative st dt. Exponential negative st dt. So this is what this theorem is saying. The question now is, how do we then get this general formula? How do we then get this general formula? Take note that anyway we'll be solving this very guy, anyway we'll be transforming this very guy to this, that becomes the general standard on solving a particular question on dividing by t theorem as far as Laplace transform is concerned, right? All right, moving on. Laplace transform of f of t, therefore the Laplace transform of f of t, the Laplace transform of f of t is equal to the integral as sigma equals to x infinity f of sigma exponential negative sigma multiplied by t the sigma. This symbol is called, in engineering, this symbol we call it sigma. We call it sigma. But for sake of Laplace transform, it refers to a dummy variable. For Laplace transform, this symbol it is refers to a dummy variable. It is refers to a dummy variable. But I'll be using sigma often. Right? Because I'm from engineering, so I'm used with engineering terminologies. So saying sigma, I should know what it means. I'm referring to this symbol as sigma. So it means, say you are given a question under Laplace transform, particularly the third theorem, which is dividing by t theorem. So this is the general formula on how it works. So from this formula, we obtain this. So the process or any steps implemented to this gives us our final result, which will be this. And that process, you implement that process to any given question as far as the third theorem of Laplace transform is concerned. As far as the third theorem of Laplace transform is concerned, right? Moving on, take note that where f of sigma is equals to the Laplace transform, where f of sigma is equal to the Laplace transform, where f of sigma is equal to the Laplace transform of f of t, where f of sigma is equal to the Laplace transform of f of t. Because that we said f of t, the Laplace transform of f of t, we define it as this, right? Meaning the Laplace transform of f of t is equals to the integral from 0 to infinity f of t exponential negative, this is our usual Laplace transform of f of t. But in this case, we said we'll be using sigma, we'll be using a dummy variable, we'll be using sigma, and we've defined the saying sigma is equals to x, or you say x equals to sigma, meaning they are similar, right? Mathematically, saying sigma is equals to x, it also implies that x equals to what? Sigma. Meaning from our usual representation of Laplace transform of f of t, anywhere you see x, substitute it as what? Sigma. In this case, f of sigma, which is equal to the Laplace transform of f of t, it becomes Laplace transform of f of t, equating that to integral from 0 to infinity f of t exponential negative sigma t. Negative sigma t. Why is sigma? We've substituted s to be what? Sigma. We've substituted x to be sigma, following the general formula of dividing by t theorem. Moving on, multiplied by what? Multiplied by dt. Multiplied by dt. Say this is equation 2. Say this is equation 2. Substituting equation 2 into equation 1, meaning the Laplace transform of f of t over t becomes the integral as sigma equals to x infinity. Substitute your f of sigma, which is this. Substitute your f of sigma, which is this. You then have integral from 0 to infinity f of t exponential negative sigma t dt, close your bracket, multiply by what? The sigma. Say this is equation 3. Say this is equation 3. From equation 3, observe that you can collect like term. From equation 3, group each integral terms together, meaning the integral for dt, group it together, then the integral for the sigma, also group it together. Doing that, it becomes integral as sigma equals to x infinity exponential negative sigma t the sigma multiplied by integral from 0 to infinity f of t dt. Say this is equation 4. Observe the difference between equation 3 and equation 4. What we only did was that we expanded, we multiply all through. By the time we multiply all through, meaning separate the function of sigma from the function of t. That is integral from 0 to infinity f of t multiplied by dt. You have this. Then the integral from sigma equals to x infinity multiplied by exponential negative sigma t the sigma. You also have this. Now the next task is to perform your integral calculus. By the time you integrate this, then multiply by this integral function, which gives you this. So let's integrate. Let's integrate this very guy. Integrating this, what do we have here? Let's integrate. Integrating integral as sigma equals to x infinity exponential negative sigma t multiplied by the sigma. How do we integrate this? Say this is equation 5. How do we integrate equation 5? Apply the idea of integral calculus. Apply the idea of integral calculus. I want to believe that every one of us watching this very video, we are higher level students, meaning level 400, level 300 students, right? So it is expected that we should be able to integrate something of this nature. It is expected that we should be able to integrate something of this nature. But for sake of simplicity, I will take you back to your basic calculus. Integrating this very function, you'll be applying the idea of use substitution from integral calculus, right? Now, given this very guy, say you want to integrate this. Your first task is let u is equals to negative sigma t. Let u equals to negative sigma t. Say equation 1. From equation 1, differentiate u with respect to sigma. Differentiate u with respect to sigma. You then have the u over the sigma is equals to negative t. So this is equation 2. From equation 2, cross multiply. By the time you cross multiply, you then have the u is equals to negative t the sigma. Right? From this very guy, divide both sides by negative t. Divide both sides by negative t. This gives me the sigma, equating that to the u over negative t. So this is equation 3. Observe that from these equations, we have equation 1 and equation 3. Equation 1 reads as u equals to negative sigma t, and equation 3 reads as what? The sigma is equals to the u over negative t. Substitute equation 1 and equation 3 into the integral function, which is equation 5. Substitute these two equations into this. So you then have integral as sigma equals to x to infinity exponential u du over negative t, right? Moving on, this gives me, integrating this, factor out your constant, meaning 1 over negative t, integral from sigma equals to x infinity exponential u du, right? By the time you integrate this, you then have negative 1 over t exponential u, right? Substituting your lower and upper limit. meaning infinity sigma equals to x. What's the value of u? From equation 1, we have u equals to negative sigma t. This gives you negative u all divided by t, infinity sigma equals to x. Substituting the value of u, which is negative sigma t, you then have negative sigma t. Now applying your lower and upper limit, meaning negative exponential negative sigma multiplied by t all divided by t minus all into brackets negative exponential negative st all divided by t. All divided by t. What we did here is that we only applied the idea of definite integral, taking your upper limit first, then subtracting it from your lower limit. So if this is the given function, if this is the function that has been integrated, all you just need to do is that anywhere you see sigma, substitute infinity, which is your upper limit, minus your lower limit. So we are still having the same function, but observe that for this one we substituted infinity, meaning that's the upper limit. Then for this one we've substituted s, which is what? Lower limit. Moving on, this gives us what? Negative exponential negative infinity multiplied by t. Infinity multiplied by t gives infinity. So the idea is that you have infinity, which is a larger number. I explained this in the previous video, right? So let's say you have a larger number, which is infinity. Infinity multiplied by a large number gives you very large number. So we are saying that infinity multiplied by a number still gives you very large number, meaning infinity itself. So what we have here simply means negative exponential always to the power of what? Negative infinity all divided by t plus exponential always to the power of negative st over t. Input this in your calculator. This gives you 0. Exponential always to the power of negative infinity gives you what? 0. So we are saying that negative 0 over t is equals to what? 0. Meaning all of this guy is being cancelled out. You have 0. Therefore, the integral as sigma equals to x to infinity exponential negative sigma t d sigma is equals to exponential negative st over t. So this is equation 6. Substitute equation 6 back into equation 4. Substituting equation 6 into equation 4, we then have integral. The integral from equation 4, we have integral of sigma from sigma, which is equals to x, to infinity exponential negative sigma multiplied by t d sigma multiplied by integral from 0 to infinity f of t dt. We can rearrange this as saying we have integral from 0 to infinity f of t dt multiplied by integral from sigma, which is equals to x, infinity exponential negative sigma t d sigma, right? Substituting equation 6 into this very integral function, this gives us integral from 0 to infinity f of t dt multiplied by exponential negative st over t, right? Observe that we have integral from 0 to infinity f of t all divided by t multiplied by exponential negative st dt, which is equals to the Laplace transform of f of t all divided by t. Recall that the general formula that defines Laplace transform is given as the Laplace transform of f of t, which is equals to the integral from 0 to infinity f of t exponential negative st dt, right? Where f of t simply means any function you want to find the transform. So in this case, the function involved is the function of f of t all divided by t, just like you have explained previously. So it is expected that the Laplace transform of this very guy should be integral from 0 to infinity f of t over t multiplied by exponential negative st dt, right? So with this equation 1, with this general formula, we've been able to derive that this guy, this integral function, integral sigma equals to x to infinity, f of sigma exponential negative sigma t the sigma is equals to the Laplace transform of f of t over t. By the time you perform your integration, we end up having this same function, which is the expected function we should have, right? So in essence, we are saying that as far as Laplace transform for the third theorem is concerned, which is divided by t theorem, this equation 1 is the general formula. The step implemented to get this same formula remains the steps to be implemented for any given question under dividing by t. So that's what this term is basically saying, right? And take note that these steps is only valid if the limit exists, if the limit of f of t divided by t as t tends to 0 exists. So this is what I'm saying. Take note that this whole steps is valid when the limit of f of t all divided by t as t tends to 0 exists. If it does not exist, meaning this whole steps is not valid, but if it exists, then it is valid. So the question now is, how do you check if it exists? So let's say you are given a particular question. Your first task is to check if it exists by performing your L'Hospital rule, right? We did that in calculus, basic calculus. We called it in the L'Hospital rule, right? By the L'Hospital rule, you are saying that differentiate the numerator, then differentiate the denominator, then substitute t equals to 0. So your answer must give a finite number, right? A finite result. When we talk about finite result, meaning you must have an integer, either 0, 1, 2, 3, 4, 5, 6, and the likes. So if it gives a finite number that is an integer, it means the limit of this guy exists. Hence, implement these steps for that very question. So let's take an example. Let's see what we are saying. Question says that find the Laplace transform. This will be our first example. So this will be our first example, but just to understand what I'm saying better before we proceed. Question says that find the Laplace transform of sine at over t. Obviously, this question is under dividing by t theorem, right? Obviously, it is obvious that this question is under dividing by t theorem. So your first task is to check if it exists. How do you check if it exists? What you just need to do is to differentiate the numerator, then differentiate the denominator. By the time you differentiated this, then substitute t equals to 0. If your answer gives a finite number, it means the limit exists, then hence perform these whole steps. So this is what we are saying. Let's differentiate this very guy. Differentiating this gives us what? Sine 80 gives us what? Have a cos. Differentiating sine 80 with respect to t, you have a cos 80, right? Differentiating t with respect to t, meaning divided by 1. Therefore, the limit as t tends to 0 of a cos 80 over 1, meaning anywhere you see t, substitute what? 0. This gives a multiplied by cos all into bracket a times 0 over 1. A multiplied by 0 simply means what? 0. So substitute 0. Cos 0 gives what? 1. Meaning a multiplied by 1 or divided by 1, which is what? A. Meaning a can be equals to 0, 1, 2, 3, 4, and the likes, meaning an integer. So it means that for this given question, say you are giving this question, which will be our first example in the next video, sine 80 over t. If this is the given question, it means that for this given question, check, or it means that for every given question, check if the limit exists. How do you check the limit? Take the derivative of the numerator and take the derivative of the numerator of the denominator, then substitute t equals to 0. If you have a finite answer, meaning the limit exists, but if you don't have a finite answer, meaning it does not exist, hence these whole steps cannot be implemented. You find another alternative method, say the numerical approach or any method, whatsoever the method is, you find an alternative way to solve that very question. So this is what the third theorem on Laplace transform is saying basically. So let's take few examples to see how we can solve question on this. Alright, if you haven't subscribed to our channel yet, do well to subscribe by hitting the subscription button below, right the corner of the screen. Alright, see you in the next video.